All right, in this example, it says when records were first kept, time equals 0. The population of a rural town was 250 people. During the following years, the population grew at a rate, so this is a slope equation of this, where t is measured in years. What is the population after 20 years? So this is not the formula to find it. This is the rate. So if we want to figure out what our new population is, first thing is, if we want to figure out what the population is in 20 years, we don't have an equation for it, but that doesn't mean we can't figure it out. We're going to find the area under the curve from 0 to 20 on this 30 times 1 plus t. I'm going to put it to a 1/2 power just so we're going to mess with derivatives. I'm going to do that. What that's going to give me is the change in the population from 0 to 20 because it's an area under a curve. So if this value turns out to be 100, then that's the change of it. But we're going to have to add that to what our original population was. All right, so here's the math we got to do, and then we'll add it to that 250. So first thing, if I'm going to do this antiderivative, let's take the 30 out. We'll bring it back later. And we're doing 1 plus t to the 1/2 power dt. So if I do this antiderivative, I'm going to have antiderivative 1 is x, t, it's our variable, t plus, if we add 1 to this, that's going to be to the 3/2 power. And we're going to divide by 3/2 or multiply by its reciprocal, which would be easier. And then we're going to go from 0 to 20. Now I am going to plug this in, so that problem's not going to be that one's not going to be a problem, but plug in 20 into this, because I'm going to have to square root the 20 and then cube it. I don't really know what that is. And then when we plug in our zeros, that'll end up wiping that away. So I'm going to go ahead and plug this into a calculator. All right, so here's what we got. I'm going to be plugging in 30, and we're going to do 20 plus 2/3 times 20 to the 3/2. So that is the first piece, and then minus, we'll be plugging in 0. So it's just going to be 0. Whatever that is, we're going to multiply it by 30. So let's figure out what that is. So if we do 20 plus 2/3 times 20 to the 3/2. Let's see what that gives us. So 79.628. So whatever that is, we're going to take and multiply that by 30 times the 79.628 blah, 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 times 30. So that gives us about 2,389 more people, about. So that's the addition in the 20 years, us finding the area under the curve is that population grew by roughly that amount, plus this 250 gives us a value about, so 2,389 plus 250 gives us about 2,639. So that would be roughly the population at that point. All right, so that was part A. Part B is, what if we just had a population equation? So find the population at any time. So that is going to be us pretty much doing the same thing. But what we're going to keep in the back of our mind is we're creating a population equation, and which means we're going to do the antiderivative like we did, but keeping in mind that our initial population was 250. So if I do that, I'm going to do that the population equation is going to be the antiderivative of our rate. And then we're going to get a plus C out of that, and then we'll plug the 250 in. So if we do the antiderivative, we did that. That was right here. So we're undoing this equation, which is going to give us this. So if I undo that, I'm going to go ahead and distribute the 30 into it. I don't need to go from 0 to 20 because that's just the antiderivative. So we would get 30t plus the 30 would get divided by the 3, but then multiplied by the 2 is going to give us a 20t to the 3 halves. And then we would have a plus c onto the end of it. And then now that's where this piece comes in. Our initial population was 250. So we'll plug in 0, set it equal to 250. So 30 times 0 plus 20 times 0 to the 3 halves power plus c. So this all goes away. So our c value is also 250. So our population equation is 30t plus 20t to the 3 halves plus 250. Now what should work really nicely is if I take this equation, I can check this answer on this equation. So if I take this and I do 30 times 20 years, so 30 times 20 plus 20 times 20 to the 3 halves plus 250, it's a population equation, and not coincidentally, it should give us the exact same thing. So we could have started with this equation and then plug in whatever value they want to do into it. So different looks, different ways of approaching the same thing.